Alright, September 2nd. Alright, it's an easy problem today. That is a signal that we will do this. We'll do the Tarjan today. We will do the Tarjan today. Alright, sum of digits of string after convert. You're given a string S, English letters, and an integer k. First, convert S into an integer by replacing each letter with its position in the alphabet. Then transform the integer by replacing it with the sum of its digits. Repeat the transformation operation k times in total. For example, if I have S as this, k equal to 2, then the resulting integer will be 8 by the following operation. So first, convert this, and this will become... well, no. This convert does not count as k. So you do the convert, and then you do the transform by adding them together once, and you add them again 2 times. Okay, so what I will do is I will convert this to the string. Yeah, that's easy. And do transformation into a string, then do it again. Yeah, sounds like doable, right? All right, let's do this. Shouldn't be too hard. All right, so first thing we need to turn it into, so we can do a string builder. All right, we can do a string builder, num_str, new string builder, okay? For char c of s dot to char array. What do you do? What we do is num_str dot append c minus a plus 1. Right? That works. Hold on. I need to read. Ooh. Append the string representation of the int. Yeah, that's exactly what I want. Alright, so now we have the string str. Then we can say, actually, let's not call it, because we have a num_str. Num builder, okay. Num builder. Okay, num builder. And then we say while k is larger than 0. Right, we will have the str. I can iterate through this, right? Yeah, I think so. I can iterate through this. Hold on. What are you thinking? Yeah, I missed here. And then we can say another string builder, temp. Right? For char c of num_str. I don't know if it's possible. Possible? Okay, only iterate over an instance of iterable. It's not iterable. Dot. Okay. It's alright. Num str dot toString. Right, and num str dot clear. Ooh. How do I clear it? Good question. Java clear string build. Is that possible? Set length 0. Or allocate a new one. Alright, let's just allocate a new one. I think it will be easier, right? And then what we do is, actually no. I get this temp, and then we will do the temp. We'll add them together. Right, we'll say rest plus equal to c minus 0. Right, and once we're done, we say temp equal to string the value of rest, and then k minus minus. Go back up, do it again, and at the end we'll return rest. Okay, let's check this. To char array. Oh, what the hell? Huh. Ba, 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 ba. 1255200. Yeah, this is right. Oh, I think I forgot to reset. Wait, which one did I delete? Oh, delete the wrong thing. Yeah, this one should be right. $19.45. All right, we'll have a new problem. We can say current and current rest equal to current current reset to 0. That should work. Right, we get this, add them into this, and then we get a current, we got this, we got a temp, go add them, get a new temp, minus this, yeah, this should be right. The hell? What? Oh, current. All right, a lot of iterations to get it right. Oh, you just do it. So what you're trying to say is I need current, right? I don't need res. I get this, get current, temp, and we reset current to 0. I'm going to do minus and minus, so I don't need this. Yeah, and then we will return integer dot pass. No, string dot pass. Wait, it's integer dot pass. Integer dot pass int temp. Yeah. Oh yeah, it'll work. That'll work. Anyway, that will be it. Alright, this is the real thing. 1568. Okay, let's quit this. No, I never done them before. $15.68. All right, so this is the Tarjan. This is the implementation of what is it called? The one. Damn it! I forgot the name. Articulation point of the implementation of the Tarjan algorithm to identify the articulation node in a graph. So I want to write it completely for myself. So what we have is the grid, which is essentially the graph. So I'll go one by one. Every time I hit something as 1, right? And if it has not been visited before, I'll check, right? I'll check to see if it exists. So what we're gonna do is we'll have a def articulation exist. Does articulation exist? Okay. So I'm passing the grid, which is a list of int. What else? I will return a Boolean value. I need to passing also because we're sharing that, right? So it will be discovery, right? And lowest discovery. And then we need a self.time. Yeah, I think we can just say time and then equal to 0, and then we just refer to it as self.time, right? Okay, so use Tarjan to detect whether an articulation node exists in the given grid. Disk discovery time during a DFS tree. Actually, we also need I, J, right? Lowest discovery. The lowest discovery time of the ancestor to the subtree that contains the current node ij. Okay, so what we're gonna do is Tarjan's algo stipulates that a node is an articulation point. A node is an articulation if and only if one of the two conditions below is satisfied. 1. The current node ij is a root in oh, we also need parents, right? We don't need parents. Ooh. Well, we'll call it tuple. Okay, so it's different. Parent is the parent node. The parent node of the current node. Of all the nodes. Right, the current node is a root in the DFS tree, and it has 2 children. 2, the current node is not a root, and its discovery time is smaller than the smallest discovery is no, not smaller, it's smaller or equal to, right? Smaller or equal to the if it's smaller or equal to the smallest discovery time of any ancestors to the current node's subtree. That is discovery ij. Oh shoot, yes, I should do it this way. Discovery ij is smaller or equal to lowest disk ni nj. Okay, so we have to make some changes here. This has to be list of int. Fortunately, this is also a list of int. Now parent Damn it. What am I gonna do with parent? It's a list of man, I don't like it. I do not like it. But what else can you do? Because you need to note if it's like a parent. Alright, so oh my god, so a tuple of int like this. Yeah, this is bonkers. This is bonkers. Alright, let's do this, right? Let's do this. Okay, so when we first visit ij, I need to know. Yeah, so the parents, I probably will do like a none. Can I do this? I forgot. I probably can. It's either none, but you don't have any parent, or you do a tuple, right? So first you need to say, okay, the current node I'm visiting, we don't say its parent, we set its children, right? Num children we set to 0 at the beginning, right? We don't have any children. And then we'll set its discovery time, right? ij shall equal to self.time, and lowest discovery time also set to, because when it starts, self.time, right? And then self.time plus equal 1, right? We increment every time. And then we shall check its, so for, oh, I also need, actually no, we can say ninj, not ninj, didj, I think this is the way we do it, right? didj in 0 1 1 0 minus 1 0 0 minus 1, right? There's 4 directions. And then ni equals to I plus di, nj j plus dj. If 0 small mn equal to len grid 0. If 0 smaller equal to ni smaller than m and 0 smaller equal to nj smaller than n, and it's the children, right? The children has to be an island. So grid ni nj is equal to 1, right? Then we can say if it has not been visited before, right? If low disk I j is smaller than 0, right? It's not been visited before, then we can say self dot does exist ni nj grid disk low disk parent. We probably should say parent ni nj equal to tuple ij, right? And now we do that. We shall say result does exist, false, no, true, no, false, wait, hold on. As long as 1 is true, right? As long as 1 is true. So I say false, right? And then we can say or equal to this. Oh shoot. Alright, it's a false, and now or equal to this. I think a bunch of other things else. Right, else means it has already been visited before. Right, so I have not been visited, but the next one has been visited. But as long as it's not, so elif ij should be fine. Elif ninj is not equal to parent ij. So we're looking for ij's child, right? And if this one's being visited is not its child, which means it can be its ancestor, then we'll reset low discovery and ij shall equal to the minimum of low discovery ij and discovery ni nj. So we want to set it to the minimum discovery time of its ancestor. Right. Okay, so here we have res is equal to false, which means that it does not exist an articulation point. Right? It does not exist an articulation point. And here num children into plus equal 1 because we have a children. Right? We'll go for the children. We'll set its parent, we set to this, and then we'll say does it exist, right? And then we'll check, right? Option and also after we're done, we should also say low discovery ij shall equal to minimum low discovery ij and low discovery ni, because I want to find its minimum discovery time from an ancestor. Right, so option 1, if parent ij is none and num children larger than 1, then we say res equal to true. Option 2, elif parent ij is not none and discovery ij is smaller or equal to low discovery ni nj. Res equal to true. Otherwise, we don't change it. And then when we're done, we return res. What do you think? We have option 1, we have option 2. There's a parent and we have 2 children, or is not a parent, but its discovery time is smaller or equal to the lowest discovery time of all its children. Okay, so now if I want to do this, we need to mn land grid 0, right? And what do we need? We need discovery shall be -1 times n for this in range m. Low discovery, basically I think it's the same thing, right? As low discovery, then parent shall equal to none times n for this in range m. Okay, parent. What else? Yep, that's about it, right? Then what we need to do is go through grid. We need to count the number of ones. So num islands, no, num land. And for I in range m, for j in range n, if grid I j is equal to 1, num land plus equal to 1, okay, and then we say if discovery ij is smaller than 0, we shall say art exists false, right? Okay, so smaller than 0, we say articulation exists or equal to self dot does exist. We have ij grid disk low discovery and the parent. I think it's giving me an error. Yeah, okay, so I think what I need to do, maybe I need to define this. I don't know. Yeah, that works. I think I can. Is this optional? I think it's called optional. Right, it's called optional. Oh yeah, that's called optional. All right, let's redo this. So we don't need this. It's called optional, and we'll add another one. Okay. All right, we'll do that, and well. So are we done? Or actually we don't need to do when we're done. Oh, we do need to do when we're done, because we need to know if numland is small or equal to 1. I think it's return 0. Right? If you have one land, then it's a 0. If you have num land and num hold on. Also num island. If it's 1, if it's smaller than that, we say num island plus equal 1, right? And then we basically count the num of land. If num of land is 0, then it's 0. If num land of 1, yeah, I think it should just... Why we count num of land? It should just be num of island. Right? You either have no island, then it's a 0. If you have one island, hold on, one island, what's one island? To disconnect. Yeah, if you only have one, like two, if you only have one, that's 1, right? If you have one island, it depends. If on one island, if it's only 1, okay, I think this is if this is equal to 0, or num islands is larger equal to 2, is larger than 1, then you return 0, right? And then I say if num land is equal to 1, you return 1. Then you say if articulation point exists, you return 1 because you return that, or I can say or art exists, otherwise you return 2. Does it work? Maximum recursion, Jesus. Oh, I think it should be discovery. No. Yes. It's discovery. Yeah, we check its discovery. Okay. Let's write a bit more documentation here. We should say go through the nodes one by one for each island, for each land. Try DFS to identify any articulation point, articulation node. Right. Can we just like get rid of it immediately? No, you can't. I think if it exists, we can already return 1. So which means maybe I can do here, if art exists, return 1. Terminate it early. Let's give it a shot. Nope. Okay, what if I comment out this? I don't know what went wrong. you cannot wait, because at the end num land is 0? No, we have land. Or num island is larger than, oh, because num island can be larger than 1. Yep, that's why. Okay, so let's try this. Nope. All right, either I got some all right, let's see. What did I got wrong? 1 2 3 4 5. 1 2 3 4 4 by 5. Da 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 da. 1 2 3. 1 2 3 4. 1 1 0 1 1. 1 1 1 1 1. 1 1 0 1 1. 1 1 0 1 1. It should be 1. You didn't find this articulation point? Huh. Interesting. Alright, let's consult to see if I did it wrong. Visited, and I didn't use visited because I can use discovery time, right? And if you check, yeah, let's put this one here. Let's compare this with your, oh my god. Okay, so children, right? Discovery is set to, initially it's on -1, which means you haven't been visited before. And then you said this is cool, and then you got this. If it has not been visited, and I say if the child has a negative discovery time, which has not been discovered yet, children plus plus, set the parent, right? And then I do this. And this one will return true or false, right? Or return true or false if it exists. And whatever it is, I'll set the rest. Okay, and then the lower discovery of u will be low of this, low of that. It's also correct. Option 1, if parent of u, which parent of this is none, and children this, I'll set it to true. Right? And once it's true, it will always be true. Option 2, if it's not none, and its discovery is smaller or equal to this, or set to true. Else, if it's not equal to parent, lowest of the parent will be the lowest of parent and discovery of v, and then return rest. I don't know why this one does not give me looks good to me. Yeah, it looks good to me. Shoot. Oh, shoot. I run both. I should run just one. Yeah. Oh, I forgot. I deleted this earlier. Oh shoot. Yeah, it was an oversight. Yeah, nothing was wrong. Num Island. Okay, let's use the other two. Num Island is one island, and then I don't have to use this. I think we can just say if articulation exists, return one. If it doesn't exist. What the hell? Oh, yes. Num land equal to 1 or articulation exists. Num land. Okay, num land. There we go. That is the solution. Using the... Oof. Still pretty tough to get it right. But I think the most important thing in this is, I think that's OMN, right? Actually, I don't know. What's the runtime? OM times N. Because this is OMN, and these only visit once. Right? They only visit once. Yep. Alright, this is, we hand rolled Tarjan. Now, to me, Tarjan, the most important part is this low discovery thing. Yeah, low discovery thing has to understand what it means, and also the two options. I mean, this one is obvious, and this one requires some thinking, right? And discovery time is easy to know. Discovery time is just the first time a node has been discovered during your DFS. And the low discovery is the lowest discovery time of the ancestor to the subtree that you belong to. Yeah, that's a little bit twist, because at the end, when you do the comparison, you are comparing, right? You do the comparison here, right? You are comparing the current node. IJ is the current node. You're comparing IJ, the current node, discovery time, to the lowest discovery time of the ancestor of everyone in the subtree of you, which is low discovery of your child. And because we do this, it's kind of compressing, like everything will be the lowest. Yeah, this is the toughest. Yeah, if you need to do a, dear me, if you need to whiteboard this, yeah, it's not gonna be simple. That is not gonna be simple. All right, that's it. Tarjan. I'm pretty sure I will forget about this, but if I forget, well, we'll just read it again. Read it again. You'll memorize one day. Okay, that'll be it. Yeah, I have to read this one more time. I forgot how to do the lowest common ancestor. Yeah, I have to read this one more time. I forgot. You don't use it. Oh, binary lifting, right? This is use binary lifting. Yeah, I have to read binary lifting again. All right, that'll be it. I will see you guys tomorrow. Adios.